Bring up my calculator, so that'll help me. Clear that. All right, so it says number 5. Find the interest that will be earned if $10,000 is invested for 3 years at 9% compounded monthly. So 10,000, 3 years, and 9%. So that'll be 0.09. So we can just go ahead and use S equals PERT. Or no, can't use that one because it's monthly. S equals P1 plus R over M raised to the MT. And compounded monthly. So our M is going to be 12 because it's monthly, because there's 12 months in a year, unless I have forgot a month. So we're going to go 10,000, 1 plus 0.09 over 12, raised to the 12 times 3. And if we plug that into our calculator, and Desmos will actually do the math for you if you didn't have this calculator, so that's fine. So I got 10,000, 1 plus 0.09 divided by 12 raised to the 12 times 3. So $10,000 investment is, so the interest you would have earned on that is basically you subtract your original 10,000. So you earn $3,086.45. Good investment or not? Right. Well, more money's more money, right? Okay. That one I think was pretty straightforward. Then number 6, it says, what lump sum do parents need to deposit into an account earning 10% compounded monthly? So monthly 10%. So that's going to be 0.10 or 0.1. So that it'll grow to $40,000. So S is going to be $40,000 for their child. Time is equal to 18 years. Okay, assuming from birth to 18. All right, so this problem is basically set up like this. You got 40,000 equals some unknown value. We want to figure out how much we want to put into it. 1 plus R 0.10 over 12 raised to the 12 times 18. Okay, now, this is one of the problems that you probably could do without doing Desmos, or you could do Desmos. It would work either way. The nice thing is you don't have an unknown. You can figure out what this is. Is that 18? You can go ahead and figure that out and then divide it by both sides. So I'm going to go 1 plus, oh shoot, I just forgot, 0.1 divided by 12. And then I'm going to raise that to the, I forget, 12 times 18. So 6.004 or 6.005. 6.005 x equals 40,000. If I divide both sides by 6.005, we're going to come out to 40,000 divided by 6.005. So if the parents had done an initial investment of $6,661.12 rounded to the nearest penny, that's how much they would have to have put in to an account to get their child $40,000 by the time they're 18. Okay. Good investment? Yeah. Yeah.
Where did the 10,000 come from?
Oh, that was a different problem. That was from the problem above. I just didn't clear it. So basically I went from here down. This was number 5. That was the interest earned on number 5. But I don't know. Would you be willing to invest roughly $6,700 to have $40,000 in 18 years? Again, it becomes one of those things. Is it's going to stay up with the cost of inflation? I don't know. Okay, but definitely something that savings accounts do definitely take place in different situations. And then number 7 says, what is the APY for a nominal 8.4% compounded quarterly? Quarterly is 4 times a year. Okay, so on the notes from the previous page, you have APY is equal to, and because we're compounding it, okay, so we're just going to go 1 plus 0.084 over 12. Oh, excuse me, over 4 raised to the 4th minus 1. And this is the annual percentage yield. So I'm going to take that and plug it in. So oops, I don't want that. I want this. I want to go 1 plus 0.084 divided by 4 raised to the 4th minus 1. So even if you're not worried about invested money, you're talking about roughly 8.7% is your average percentage yield. So it goes pretty simply. Questions on that? Did anyone not get that done now? Or is everyone done? You're done because I did it. Question? Same done?
Yeah, same done.
Yay.
I actually have a question. Why on this one do you put 0.1 on this one you use the decimal? Why don't you move it on this one?
I did 10% and decimal right here. So I'll move it over twice. This one was 8.4, so move it over twice.
Okay, I see.
That's a 4 class.
Yeah, thanks for that.
We're good. All right. All right. Okay. Let's go to the back side and let's see. Number 8, figure shows a graph. $100 8% annually, along with a graph 100% 8% compounded continuously. Which is which? Continuous growth is going to have the faster. Okay, so continuous will grow faster than compounded annually. Annually means it compounds once. Continuous means it compounds nonstop. So that should help you with that. Number 9 says a shareholder who purchased 100 shares of Federal Signal Corporation stock for $1,438 at the beginning of 1979 and reinvested dividends, would have had investment worth $50,620 at the end of 93. What interest rate? So that's going to be for number 9. You would use the S equals P plus 1 over R over M, raise the MT, and what you're going to do is you're going to graph both sides on Desmos and tell me what the X value is of where they intersect. Okay, so that's the wrong thing. Go here. So just so you know, on number 9, for some reason my computer is being a little finicky. So for number 9, you're going to use this equation. I think that's the one we'll use. Reinvested dividends at the end of 93, compounded annually. So annually means your M is 1, and you're going to make your P value, you're going to turn that into an X, and then you plug Y equals whatever the S value is. So S would have been 5620. And then the other one you would do 1438, 1 plus the rate we don't know, right? Yeah, we don't know this. And this was compounded annually. 1 for 79.93. So 10, you're talking about 14. So you're going to graph this and this and figure out where they crisscross each other, and whatever the X value is, that's what you want. That'll be your time. Is that okay? And then you try and figure that out. At what nominal rate, compounded quarterly, would 20,000 have to be invested to the amount to get 26, 425, 82 in 7 years? That's going to be very similar. Number 10, you're still going to use the same equation. You just have to plug in. You have to graph both sides. For her birthday, Polly. Anyone know Polly? I know Polly Graph. I'm kidding. Invested $1,000 in an 18-year-old certificate that pays 8% compounded annually. How much will the certificate be on her 19th birthday? Okay. So this is going 1 year beyond that. So you're going to go ahead and use on number 11. It was continuously. Oh, compounded annually. So you're going to use this one. And that one was number 11, compounded annually. So M is going to equal 1. And you'll probably have to graph. You could just plug into that. You're looking at $1,000 is your P value. And then on the night for her first birthday, so your time is going to be 18. And if I read that, 18 years. And rate is 8%, which is 0.08. So you can plug that in and find that. Then number 12 says a couple needs $15,000 for down payment on home. If they invest $10,000, they have 8% compounded quarterly. How long will it take the money to grow to $15,000? So you're going to use the same equation, but you're going to have 15,000 is equal to the 10,000. 1 plus 0.08. I ran out of room. Let's see if I can move this. Come on. Kind of moved. So 1 plus the rate, 0.08 over quarterly over 4 times X. Graph both sides, figure out where the two graphs intersect each other, looking for the X value. That's what you want. That's the time. And then number 13, a house was 20 years ago was worth 160,000, has increased by a value of 4% each year because of inflation. What is it worth today? So 13, if you need me to go back, let me know. So time is 20. It was worth this much. Hi. Gotcha. Thanks. Or wait, let's see. Andrew's not here. Never mind. I thought he was here. He's not here. I'm sorry.
Thank you.
160,000 is our initial investment. So that's going to be your p-value. And your rate is 4%, which you would plug 0.04 in. And you're solving, and you're going to use this equation. And that should solve that very nicely for you. And 14, suppose a country has a population of 20 million, projects the growth rate of 2% per year for the next 10 years. What will the population be in 10 years? So this works same with that. We're going to use S equals P RT. So your p-value is going to be 20 million. 1, 2, there, 1, 2, 3. Is that 20 million? Yeah. And then I have the rate is going to be 0.02. And then that will solve all the rest of those. So, will you finish the back of, you just have to do those problems I did. Finish the back of Finance 6.1. And I'll give you the rest of the period to work on it, so hopefully you can knock it out of the park and get it done for me for tomorrow. Sound like a deal? Did you get the homework?
Yeah.
I put you in.
Awesome. And then for number 4, is this right here? So we have to